Hi, welcome to myprojectbazaar.com. Now we are going to see about the project, a rough set based incremental approach for updating approximations under dynamic maintenance environments. In this paper, we focus on the variation of granularity in RST, rough set theory. With the variation of an information system, the equivalence classes in the information system may vary over time, while the granularity of the information system also evolves over time. The variation of an information system may vary over time. When the information system is changed, it is highly time consuming to reprocess the whole operations for getting the new results. Therefore, it is important to avoid unnecessary computations by utilizing the previous data structures or results. Generally, incremental updating is an effective method to maintain the knowledge dynamically, and it has been used to data analysis in the real-time application. Now we are going to see the DFD diagram. First, load the dataset. Next, pre-process the dataset in order to remove the unwanted elements. From the dataset, hierarchy is found based upon the decision attribute. Load the distinct attribute values in their respective granularity tables. For the insertion and the deletion of an object, we are using the incremental based approach in order to maintain the granularity. While inserting an element, first we need to check whether the attribute is already present in the table or not. If it not, update the table. Otherwise, add the attribute and check D is present or not. If it is present, compute the lower approximation with the inserted element. Otherwise, compute lower approximation and add the element to the hierarchy. Next, compute the lower approximation and the upper approximation of an element. Check whether the element is the subset of lower approximation or not. If it is present, leave it. Otherwise, eliminate element. Check the element is the subset of upper approximation. If it is present, eliminate element. Otherwise, leave it. Next, we are going to see the deletion algorithm. First, check the attribute is present or not. If it is present, means eliminate that element. Otherwise, update the attribute. Next, check the decision attribute is present or not. If it is present, compute the lower approximation with that element. Otherwise, compute the lower approximation and add the element to the hierarchy. Finally, compute the lower approximation and upper approximation of an element. Check element is present in the subset of LA or not. If it is present, means eliminate element. Next, check the element is a subset of upper approximation. If it is present, eliminate element. Now we are going to open the project. The front end is in NetBeans and the back end is MySQL. In the front end, click First Start Java and then Run File. Click Next. Browse the dataset. File is selected. Load the values into the database. Next, and the values are shown here. We can show the hierarchy of each element and then click Next. The hierarchy is found based upon the decision attribute. Two hierarchies are found, type 0 and type 1. Those values are loaded into the database. Click Values. Finally, the attribute, that is the distinct values for each attribute, are shown here, and then choose Process. If you choose Object Insertion, means it will move on to Insertion page. Click Insertion Values and give the values, enter the values. If that animal has the property, enter 0, otherwise 1. Finally, the values are checking here and the values are inserted, and then the inserted value is shown here, granularity. Finally, the distinct properties for distinct elements of granularity tables are also shown here. Finally, the performance. For the object deletion, we need to choose the object deletion and then click next. We need to delete the element. So I'll choose ampere, delete. So it will delete it. And finally, the granularity tables are shown here and performance. Thank you.